Now say next question. Represent the following complex number in polar form. So first we again discuss what is polar form, what is Cartesian form. We know that if z equals to a plus bi is complex number, we write this complex number in order pair or in point form as ab. Or if you compare with x plus iy, we get order pair xy. That means this is Cartesian form. When we replace this xy in terms of r and theta, that means in terms of modulus and argument, that is x is equals to r cos theta, y is equals to r sin theta. Or if you compare with this AB, then we write a is equals to r cos theta, b is equals to r sin theta. So in place of xy, if we write that as point P and this coordinate xy as p of r theta, that means this we replace x by r cos theta and this y by r sin theta. This is polar coordinate form, this is Cartesian coordinate form. So we have to compare the given equation with equation z equals to x plus iy or z equals to a plus bi. Then we have to find r first, then we have to find theta. So we see solution of first of question. Number 1, minus 1 plus root 3i. So we compare this with x plus yi. Now suppose this is z, we consider z equals to x plus iy. So we get here x is equals to minus 1, y is equals to root 3. That means we write this in coordinate form or in point form or in order form as minus 1 root 3. Now first we observe this point, either lie in first quadrant, second quadrant, third quadrant or fourth quadrant. Now here this x coordinate is negative, y coordinate is positive. That means this point lie in second quadrant. So the angle calculated, that means theta calculated, must lie between 90 to 120. Why not 90? Why not 180? Because point not lie on x-axis or not lie on y-axis. So this point must belongs to second quadrant. So first we find value of r, that is modulus. Therefore r is equals to under root x square plus y square. That is under root x is minus 1, so write minus 1 square. Y is root 3, so write root 3 its square. So we get here minus 1 square as plus 1, root 3 square as 3. So we get 1 plus 3, 4. So square root of 4 is 2. That means value of r is 2. Now we have to calculate the value of theta. So we know the formula, tan theta is equals to b by a, or in place of b here value is y. So we write tan theta is equals to y by x. Now substitute the value of y as root 3. So write root 3 upon value of x. Value of x is minus 1. So we get minus root 3. Now we have to find the value of theta. So we write this as tan theta is equals to minus. Now we have to see here for which angle we get tan as root 3. So we write tan pi by 3, that is tan 60 is root 3. Now for comparing theta equals to pi by 3, we have to convert this minus sign to plus sign. So for that we use the formula. In second quadrant, tan pi minus theta is equals to minus tan theta. So write tan pi minus, in place of theta we have the value pi by 3. So tan pi minus pi by 3 is equals to minus tan pi by 3. So we write this as 3 pi minus pi, that is 2 pi by 3, which is equals to minus tan pi by 3. Now we replace this minus tan pi by 3 by this plus tan 2 pi by 3. So we write here tan theta is equals to tan 2 pi by 3. Therefore theta is equals to 2 pi by 3. So we write here this pi by 3 as 60. So 2 into 60 we get 120. That means this 120 lie in second quadrant. So our calculated angle is satisfy this condition because this point lie in second quadrant. So if we draw a rough diagram here, suppose this point minus 1 root 3 is here, and when we join with origin, then this inclination is 120 degree. So we get the value of theta, we get the value of r. Now we have to find polar form, that means x is equals to r cos theta, y is equals to r sin theta. Therefore x is equals to r cos theta implies x is equals to, now substitute the value of r as 2. So we write 2 cos, here theta is 120, or you can write 2 pi by 3. 2 pi by 3. Then y is equals to r sin theta. This implies y is equals to 2 sin 2 pi by 3. That means we have to find the value of cos 120 and value of sin 120. First we find this cos 2 pi by 3, that is cos 120. So this 120 can be written as 90 plus 30. So we write this as cos 90 plus theta. We know the formula, cos 90 plus theta is equals to minus sin theta. Here in place of theta we have the value 30. So we write cos 90 plus 30 as minus sin 30, and sin 30 is 1 by 2. So we get cos 2 pi by 3 as minus 1 by 2. Then next we have to find, therefore sin 2 pi by 3, that is equals to sin 120. Again this sin 120 we write as sin 90 plus 30, and sin 90 plus 30 is cos 30, because sin 90 plus theta is equals to plus cos theta. So cos 30 is root 3 by 2. Now we have the value of cos 2 pi by 3, that is minus 1 by 2. We have the value of sin 2 pi by 3, which is root 3 by 2. So substitute these values. So we write here x is equals to 2 cos in bracket is 2 pi by 3 is equals to this cos 2 pi by 3 we calculate as minus 1 by 2. So we write minus 1 by 2. These 2 get cancelled, which is equals to minus 1. That means we get x is equals to minus 1. Similarly, y is equals to, we have the value 2 sin 2 pi by 3. We calculate this sin 2 pi by 3 as root 3 by 2. Root 3 by 2. These 2 get cancelled. So we write here this as root 3. Now check these values. We have the value of x as minus 1, value of y is root 3. So we have to confirm the angle. That means after substituting the value, we get the value of x as minus 1, value of y as root 3. That means this angle we calculate is right. So we write here the polar coordinate form. There is no need to calculate this value, but this is first example, and how to check the angle. For that we substitute the values and confirm the angle. So you have to just write here P of r theta is equals to, now substitute the value of x as 2 cos 2 pi by 3, value of y as 2 sin 2 pi by 3. So you can take 2 common. So 2 in bracket cos 2 pi by 3 sin 2 pi by 3. So in this way you can write the answer, or you can write this in this way also, cos 2 pi by 3 plus sine 2 pi by 3 I. So this is polar coordinate form.